So we talked about arithmetic sequences. So an arithmetic sequence, remember, was one like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Where there's a common difference, there's something that we add each time to get the next term. If you take and we wanted to add those together and make it be 1 plus 2 plus 3 all the way up to 10, so this is called an arithmetic sequence. This one is called an arithmetic series. When we add the terms of an arithmetic sequence. So you can see that it's arithmetic still in the fact that I just add 1 to each one of them to get the next term. We could just add these up and come up with a total. But imagine that if this was 1 plus 2 plus 3 all the way up to 5,273. I don't think I'd want to take a calculator and have to try and add those up. I would want to try and see if there's a faster way of doing it. And so to develop a formula for it, what we're going to do is take that series that we have right there, and we'll just call that S, the sum, 1 plus 2 plus 3 plus 4 plus 5, all the way up to 10. And now if I wrote that series the other way around, 10 plus 9 plus 8 plus 7 plus 6 plus 5, all the way down to 1. And then I were to add these two things together. I would get 2 times the sum would equal 11 plus 11 plus 11 plus 11, and then plus 11, 6 and 5 is 11, 7 and 4 is 11, 8 and 3 is 11, 9 and 2 is 11, and 10 and 1 is 11. You can see that we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 11s. Okay? So what this is 2s then equals 10 times 11, or s equals 10 divided by 2 times 11. Now you notice this 11 came from really adding the first term and the last term. So that's a sub 1, and that's a sub n, you might say. And so we can come up with a formula for finding the sum of an arithmetic series. Just by doing that. Notice this 10 is how many numbers I had. I got 10 numbers, so that's 10 divided by 2, and then times the first term plus the last term. So the sum of the first n terms then, the formula is just the number of terms divided by 2 times the first term plus the last term. So there's our formula that we're going to use. And I'm going to do a few examples, kind of like what's on the worksheet, so similar to what you're going to have for an assignment. We're just going to use that formula. So let me grab the examples I have. So let me zoom in here. If we look at the first one, I'm not going to do all of these, but let's say we were to do number 2. So I want to find the sum of these numbers. Well, yeah, it'd be pretty easy to just add those up. But what we can do is we can see this as arithmetic. So 36 plus 10 is 46, plus 10 is 56, and so on. So the common difference is 10. If I want to find the sum of that, then I know that n equals 1, 2, 3, 4, 5, 6. The first term, a sub 1, is equal to 36, and a sub n is equal to the last term, which is 86. My formula again is S sub n equals, n divided by 2 times a1 plus a sub n. So it's just a matter of substituting in here. The sum of this is 6 divided by 2 times 36 plus 86. And so then you just take your calculator, clear that out of there, and I go 6 divided by 2, and then times parenthesis 36 plus 86. And the answer is 366. And you could find out if you added those up, that's what it would add up to. Okay? Now sometimes the problems are written a little different form. Rather than actually give you the sequence itself, they give you some information about it. So let's say number 6 here. They give me that a sub 1 is 1, a sub n is 96, and n equals 20. So again, if we look at our formula, S sub n is n over 2, a1 plus a sub n. They give us all the information we need. They give me n, a1, and an. So it's a matter of plugging in there. S sub n then equals 20 divided by 2 times 1 plus 96. Take your calculator, and so 20 divided by 2, parenthesis, 1 plus 96. And the answer is 970. And there's the sum of that sequence. Now, sometimes the series are written, easy for me to say. Sometimes they're written in what's called sigma notation. And it's just a shorthand way of writing the series. What it is it uses a thing, it's a capital Greek letter called sigma. And what there is there's n equals 1 to 10 up here. And then there's a little expression here, like 6n. And what that is each time we let n be 1, so the first term is going to be 6. This is a shorthand way of writing the series. If I put 1 in there, I get 6. If I put 2 in there, I get 12. If I put 3 in there, I get 18. And I keep doing that all the way up until I get to the top number, which is 10. So put 4 is 24, 5 is 30, 6 is 36, 7 is 42, 8 is 48, 9 is 54, and 10 is 60. So I could just go ahead and add all of those up. But again, I can use my formula right up here a lot easier. I know that there's going to be, if I count from 1 to 10, that's 10 numbers. So n is going to equal 10. A sub 1, we need that. Well, a sub 1 is what we get when we put the bottom number in there. So put 1 in there, I get 6. A sub n is what I get when I put the top number in there. So this is the bottom number, and this is the top number. I just put it in this expression right here. So if I put 10 in there, I get 60. Now I know the information to go into my formula right up here. So S is going to equal n divided by 2 times a1 plus a sub n. 60. Take your calculator and you work that out. So 10 divided by 2, parenthesis, 6 plus 60. Oops. I don't know what I did there. And the answer is 330. So back to the sheet that I have for examples, let's look at an example of one like this. Let's say that we're going to go from 1 to 20 of 10n minus 18. So the number of terms is just think of counting from 1 to 20. N is going to equal 20. A sub 1 is what I get when I put 1 in there. So n equals 1. When I put 1 in there, 10 times 1 is 10, minus 18 is negative 8. A sub n is what I get when I put the top number in. N equals 20. So if I put 20 in there, 10 times 20 is 200. 200 minus 18 is 182. Now I know the information I need. Again, my formula is n over 2 times a1 plus a sub n. So s sub n is 20 divided by 2 times negative 8 plus 182. Put that in the calculator. So I clear that. 20 divided by 2, negative 8 plus 182. And the answer is 1,740. And that's how you find the sum of an arithmetic series.